Hi, welcome to the Chemistry Lab. I'm Adam Clayman. Today, we'll walk through some of the basics of what you need to know before working in a laboratory. Safety is always the first thing we consider, and that starts with what we're wearing. Lab-appropriate attire includes shoes that cover the entire foot, pants or a skirt that covers the entire leg, a top that covers the torso and shoulders, and critically, chemical splash goggles that create a seal around the face, and they should have a Z87 rating somewhere on the frame. You should purchase your own pair of goggles, which may be available online or at your campus bookstore. If you are lacking lab-appropriate attire, you will not be allowed in the room. Now, I'm ready to enter the lab.
You may also be required to wear gloves when handling certain chemicals. Gloves will always be available to you and are encouraged for general chemical handling. If you have a latex allergy, be sure to ask your instructor about receiving nitrile gloves. A lab coat can also be worn for additional protection. Beyond what you wear, there are other safety features you need to be aware of in the laboratory.
If any chemicals get in your eyes, there's an emergency eye wash near the door. Push the paddle to activate the water and place your eyes in the stream for up to 15 minutes. Each sink also has a sprayer that can be used as an eye wash. If you're covered in chemicals, there's a safety shower right above the eye wash.
Always be aware of where multiple fire exits are. In this room, there are exits to the south and to the east. In the case of an electrical fire, there is an emergency shutdown switch near the door.
Fire alarms can be found near the staircase doors in the hallway. Just outside the lab door is a fire extinguisher. It's held from the bottom of the handle and the pin is pulled, after which the top can be compressed to release the spray.
When using harsh or toxic chemicals, it's a good idea to work inside a fume hood. Air is constantly being pulled through the fume hood so that any chemical fumes generated within aren't inhaled by the user. The fume hood should stay closed when not in use, but when I'm ready to use it, I'll simply lift up the sash. I want the sash to not go above the red line, but I can operate it with it lower. It helps to keep any chemicals I'm working with about 6 inches into the hood so that no fumes escape. Most of the equipment or glassware you'll need is in your lab drawer. Make sure to use the drawer that corresponds with your section number. Equipment that is shared between sections is stored in the middle drawers and the cabinet. If you're missing a certain piece of glassware, it may be found under one of the fume hoods in these cabinets. If you need a specific amount of any chemical, you can weigh it out here in the balance room. Using a balance is pretty simple. Let's walk through it. The first thing to do before taking your measurement is to zero out or tare the balance, which can be accomplished by pressing 0/T button. For a container, we can use a folded piece of whey paper, which is nice for pouring into a smaller vessel, a whey boat, or just a beaker. Glass vessel is probably best for any liquids. Now that the balance is zeroed out, I'll put my whey boat on the whey area, making sure to close the door after. It may take a second or two for the mass to settle. At this point, I have two options. I can record the mass of the container, remove it, add my chemical to it, and reweigh the whole thing, or I can tare it once again. So now the balance is incorporating the weight of the container. Now that my weigh boat is zeroed out with the balance, I'll remove it and scoop the chemical out outside of the balance so that I don't make a mess in there. Notice that the mass reading is now negative because that's the weight of my weigh boat. And when I put it back on, now I have just the mass of the solid I added. Now I can remove my weighed chemical. But before I leave, I have to make sure to clean up the balance area. First, I have to make sure to cap any chemicals. Then I should clean up any spills. If I spill anything directly on the balance, I'll make sure to use a brush clean it up. For large spills, a dustpan is available. Don't return any spilled chemicals to their original bottle. Once they touch the counter, they should be considered contaminated. Now that the balance is clean, any spillage is mopped up, and the container is capped, I'm ready to walk away. It's important to keep the balance area clean, as hundreds of other students use this area. Graduated cylinders are often used to measure liquids. Let's say I want to measure 50 milliliters of water in this graduated cylinder. In order to get an accurate reading, I have to make sure to be at eye level with the liquid. The very top of the water is called the meniscus, and you may notice there's a slight curve. I want to take my volume reading from the very bottom part of the meniscus.
When taking a reading, we estimate to 1 digit past the marked lines. In this diagram, the meniscus is closer to 45, so we'll estimate the reading at 45.2 milliliters.
Right now this looks like about 48.5 milliliters. I can deliver a small amount of volume with a dropper. Now I have precisely 50 milliliters.
Dimensional analysis is a vital chemistry skill. It allows you to convert one value into another using some ratio or conversion factor. Let's look at an example. A student measures 14.3 milliliters of ethanol in a graduated cylinder. How many grams of ethanol is this? I need to end up with units of grams, and I'm given units of milliliters, so I need to find some conversion factor that relates milliliters to grams. Density just happens to be a factor like that, and I happen to know that the density of ethanol is 0.789 grams per milliliter. So I'm going to start by writing down the value I do know, 14.3 milliliters, and I'll multiply that by the conversion ratio to get to the units I want. Notice here I've put milliliters on the bottom so that those units cancel out, and I'm just left with units of grams. If I multiply that out, it comes to 11.3 grams. Now let's try a more difficult problem. How many ibuprofen tablets would be a fatal dose for a person weighing 152 pounds? And we know that one tablet is 200 milligrams, and the LD50 is 636 milligrams per kilogram. The LD50 value is what denotes a fatal dose. What it's saying is that for every kilogram of body weight, it'll take 636 milligrams of the substance, ibuprofen here, to be fatal. So I'll start with the value I know, this person weighing 152 pounds. Before I do anything else, I'm going to convert this mass unit of pounds into kilograms so that it can cancel out with some other units. I happen to know that the conversion ratio of pounds to kilograms is 1 kilogram for every 2.2 pounds. Units of pounds cancel out, and I'm left with just kilograms. Next, we'll multiply by the LD50 value. Here we see the units of kilograms cancel out. Now there's just one more conversion left. We need to figure out how many tablets are contained in this many milligrams. So we'll use our given ratio of 200 milligrams per tablet. Units of milligrams cancel out, and now we're left with just units of tablets. If we multiply that out, we get 220 tablets. You should read through the full write-up of dimensional analysis in your manual. It's a vital skill that will come back in nearly every experiment. For each experiment, you'll complete a lab report. On the Moodle page for your section, each experiment has its own area. Click on that and find this report item here. If you click into that, we can see the submission button and the report template. It's a doc file, so I'm going to download that. I'll open it in Word. Here I can see all the report questions. You should be well equipped to answer these if you completed the procedure and analysis in the manual. In Word, if you need to write a chemical formula, make sure to use subscripts. Here's the formula for ethane, and I need these two numbers to be subscripts, so I can just click this little subscript button up here. Sometimes you're asked to show calculations in a report, and there's a number of ways to do that. For one, here's a photo I took of my handwritten work, and I emailed myself an image file of it. I can just drag and drop it right into Word, and maybe I'll even crop it down a little bit to save space. You can also use a document scanner app, there's plenty to choose from. Or you can use the equation function in Word. Just go to Insert, Equation, and then you can type whatever in here. See, we got our mathematical operators up here, and I'll often use this fraction function. And if I want to get fancy, I can even use the strike through feature to cancel out units. Once you've put all your answers in and you're ready to turn in your report, make sure to export it as a PDF file. There's a couple of ways to do that. Go to File, Save As, and you can select PDF from this dropdown, or you can go to File, Print, and print as a PDF, or you can go to Export and export as a PDF file. If you're using Google Docs for your reports, it has similar features. Here's that chemical formula again, and I can go to Format Text and use this subscript function. You can see there's also a keyboard shortcut for it. Google Docs also has an equation function. It's under Insert, Equation. And it has many of the same functions here. Here's that fraction. Here's operators. And when you're ready to export to PDF, simply go to File, Download, PDF. Once I have my PDF file in hand, I can go back to this page and just click the Submission button and find that file on my computer and upload it.